Oh, it's Max, and we're back. Here we are. That's right, man. Equatorial mounts. That's what I get. That's what I get. Oh, man. Just these, the flat earth would have everything locked down tight with every possible provable thing. We almost had it. We almost convinced the world. Unfortunately, apparently, equatorial mounts disprove the flat earth. Oh, let's take a look at this. Being something of an amateur astronomer myself, this one just kind of infuriates me a little bit. Just a little bit. This was a comment that kind of rolled over to my other channel where, someone wanted to call me dumb because of equatorial mounts. And I'm like, well, why don't you explain that? And of course they can't. They don't know how an equatorial mount does anything. They don't. But they're going to say, oh, it disproves the flat earth. Well, it actually proves the earth is flat. This is how retarded people are, all right? This is how stupid globe earth people are. They got nothing left to grab onto but telescopes. That sounds scientific. Equatorial mounts. How does an equatorial mount work, sir? And it works on the globe. Sir, could you please explain how that equatorial mount sets up and why it only works on a globe? Equatorial mount. Neil deGrasse Tyson said it's an equatorial mount. And there's a diagonal lights, and we look at that stuff. Okay. All right. Why does an equatorial mount disprove flat Earth? An equatorial mount is a telescope mount, where axis is aligned parallel to the axis of the rotation of the Earth. Really? Do you think the telescope knows the Earth is rotating? Do you think that you're putting in the calculations in the miles per hour of the rotation of the Earth into your little telescope there to make it so you can look at the stars and not have to monkey with the telescope every time the stars move? Do you think you're putting in the calculations for the rotation of the Earth, people? Do you think the telescope knows that it's zooming through the galaxy at 1,000,000 miles an hour, rotating at 1,000 miles an hour, all this yippity-boo-bah? No. The telescope thinks it's sitting on a flat surface. As a matter of fact, you tell the telescope you are sitting, Mr. Telescope, on a flat, stationary plane, and you are perfectly level, and you are not moving. Furthermore, you take Mr. Telescope, and you tell it where the North Star is. Here is a picture for you. You tell Mr. Equatorial Mount Telescope that you are on a flat plane, and you are at a certain degree pointed directly at the North Star. The telescope doesn't know nothing. You're the one putting in the information. Okay? Does this look like it's on a ball? No, it is on a flat surface. Want to know why? Because it's all based on geometry. What does geometry use? Triangles. Now, you give me a triangle off that ball. You give me triangle. No, we are assuming flat plane. The equatorial mount only works on a ball. Excuse me, the equatorial mount was invented in like 17 or 1800. When everyone thought the Earth was flat. Wouldn't it be kind of stupid to make an invention for something that didn't exist yet, called globe Earth? I'm sorry. Let's keep going here. This has to do with the different axes of movement. Therefore, a single axis movement can cancel out the Earth's rotation to keep it pointed at a celestial object for a longer time. This is well proven to work. Big deal. A flat Earth with stars' rotations concentric about the northern celestial pole will require always correction around two axes to track the star. The polar axis of an equatorial mount will always be not aligned with the celestial rotation of the flat Earth. Blah, 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 blah. Therefore, the fact that an equatorial mount works perfectly is in no way compatible with the flat Earth. Blah, 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 blah. Science and stuff. Hey, you're setting up your telescope on a flat plane. Okay? Equatorial mount. The Wikipedia. The Wikipedia, man. Wikipedia, they never lie. They never lie. Somewhere in here it tells me where it came from. It's like 1700s or 1800s. Clock drive, blah, blah, blah. Well, whatever. You're going to have to take my word for it. It's on here somewhere where it says where it's invented. Anyways, long before people decided that we're on a spinning ball. Okay? Now, I want you to take a look here. We'll look back at this. Okay? This is so you can track the movement of the stars in the sky. This is not to counteract the rotation of the Earth. The telescope assumes that you are flat and stationary, and you are looking at something moving. Just because it's called an equatorial mount has nothing to do with the equator, guys. Something may throw people off. Okay? But all of your latitude, longitudinal, all that stuff is based on your degrees looking up at the sky with a sextant based from a flat plane. I want to look at this guy for a minute.
All we've got to do is re-establish that the telescope mount points to that axis of rotation, because now everything's rotating about a point that's at
the
some
North
angle,
Star.
Not our latitude.
See, right here, he's got the little point.
Horizon. So if you look at this mount again, and we imagine setting, instead of having it horizontal, or instead of having this at a 90-degree angle, we set that angle to the latitude of where we are. So we can do that.
There you go.
We've got a scale on the back of the mount here, which allows us to set our latitude.
Oh, in degrees of a triangle.
We set it
wow.
So that
it's mysticism, man.
It's pointing
this is mysticism.
To the north. So this direction is north. And
because you tell it.
We've established that we've set the angle correctly so that this axis of rotation is now pointing at Polaris. So Polaris is now up there.
Why would you do that? Because it's a reference point that doesn't move, right? So this is most of the time they have like a little eye peep sight, right? A peep sight in here so you can point this thing dead reckoning right lined up with the North Star. And you know what? The old North Star doesn't move in thousands and thousands of years. Isn't that kind of funny? Isn't that kind of funny? Kind of proves that the Earth doesn't move, doesn't it? You can set this telescope up and come back to it 10 years later, and this little part right here that points to the North Star is still going to be pointing at the North Star. Kind of throws out that idea we're zinging through the galaxy, doesn't it? Kind of does. Huh. So anyways, because all stars rotate around the North Star, at least in the Northern Hemisphere, very nicely. In the Southern Hemisphere, there's a little different thing going on down there. But they don't all rotate around a single star, like in the North Star. And then we have this little mount here, basically allows to rotate and follow a star around in a circle. Why this could not work on a flat plane, I don't understand their reasoning. They came up with a bunch of gobbledygook because of such and such trigonometry, x equals pi r squared, something. No, the telescope assumes it is on a flat plane.
We find that star again, and all we need to do is move the equatorial mount in that one dimension, just like we did when we were on the North Pole, and we'll follow that star. So basically, in a nutshell, an equatorial mount is simply an altitude azimuth mount, like this.
Blah, blah, blah. It's a drafting tool with a telescope on it. That's what it is, okay, for making circles. That's it. So you can make a circle and follow the stars. Not a huge big deal. Let's take a look at aligning. Let's align an equatorial mount. I don't know why they call it equatorial mount. They just call it a telescope.
There, and that's pretty close. It's not dead on, but it's close enough that I'll be able to use the fine adjustment. So now what I want to do is actually level the telescope.
Oh,
there's
what?
A bubble level.
You got to wait. You're leveling the telescope. Hold on now. Hold on. Leveling the telescope, because we're on a ball and it doesn't work on a flat Earth, right? So, but we have to level the telescope. What if I'm over here on the side of the earth? What if I'm over here? What if I'm down here? What if I'm over here? You want me to level the telescope? How does leveling work when I'm on the bottom of the ball? How does that work? Tell me, smart man.
Particular mount, so that helps
Oh,
me
look.
to level it. If
How
you
does
don't have
this
that,
work?
There's a couple different ways you can do
How does that water go upside down and actually mark exactly whether or not something is level or not? How does that work?
One is you can use a plumb line.
A plumb
Which is
line?
just a weight.
How does this plumb line work on the bottom of this ball?
With a string on it, and you can actually hold that right underneath the center of the telescope here and have it drop down right in the middle of where your tray is, and if that's centered, then you'll be all set.
Huh. You know, you guys are making this thing remarkably stable, remarkably flat, and remarkably level for something you say can only work on a ball. Amazing. It's amazing. Hold a level.
And
like a sea level?
Just like that, I've got a good level with my bubble level here.
Uh-huh.
We need to make sure that we are aimed in the correct direction. So I'm going to pull these open like this, give myself plenty of room.
Wow.
That way I can spin them out like this.
Uh-huh.
I'll bring my compass back out.
Oh.
The thing that you need to know about a compass is that magnetic north is not the same as true north. So while I have this aimed directly at magnetic north right now, my actual location from where I am is about 4 degrees off of
Degrees,
true
huh?
north. So I need to adjust for that. And then I can use these to
almost
even
like
refine that
triangles.
just a little bit further
That
if I
require
need
the flat
to.
plane.
And then also lock it into place so that it won't move during my observing or
Oh,
astrophotography session.
that's amazing. That's amazing, setting up everything to be perfectly stationary, flat, and level. Apparently, he must be doing this from the North Pole, the only place that you could actually have a flat plane like that. I don't know. Maybe he's in the middle of a lake. No, lakes bend too, according to globe stuff. So this only works on a globe model Earth. Okay. Now remember, it took all this time to set this thing up to make sure that it was on a flat plane and it was level and it had the plumb line out there and we had the little bubble of water, right? That's trying to find the center because of density and buoyancy and all that good stuff. All that science that people actually use in real life. Explain to me, sir, how does it work when we're on one of these little things shooting through the galaxy, right? How does that work? Maybe I'll do this one. Let's do this one. How does that work when we're on this thing spinning through the cosmos? How does our equatorial mount work on that? How does the equatorial mount work? The North Star is always in the same place. How does that work? Anyways, there you have it. Equatorial mount shenanigans, garbage, crap. Oh, the equatorial mount, it proves the flat Earth. Or proves the globe model. No, it doesn't. It proves the flat Earth. All right? Back when this thing was invented in the 1700s or whatever, this is just a variation on the stuff that people use out in the boats at sea. Okay? If nobody's got the North Star or they've got anything else over like in the equator where everybody travels by boat, when they're looking at the skies, how does any of that work? How would any of that stuff work? Your equatorial mount and all this garbage if you're on a ball. It doesn't. And while we're on the topic of telescopes, don't ever buy one. They're a waste of money. This guys want $4,000 for a 10-inch telescope. That's a little motorized. And it works off serial port technology. Serial ports, guys. In 2020, they're still selling these for $4,000. Serial ports. You can't even plug a USB into it, right? To use with your laptop. These are gatekeeped. These are totally gatekeeped. right? I used to be into the amateur astronomy stuff, and I spent like $1,000 between all the different stuff. This SL, here it is. I got this one, and I also have another one too. Down here, I got something like this also. I got them both, right? They're serial port technology. This stuff is like 30 years old. The stuff that they're buying and they're selling to you as new. And look at this. $500 for this piece of junk. $500. And the what do you call it? They measure things in like focal length. All right? Focal length. So this one, I don't know. It's a piece of junk. You would think that it would be better than a camera, though, or a pair of binoculars. No, they're about the same as a pair of binoculars, except you get to spend $400 for it. And then, $100 in lenses and all this other stuff. Total waste of money. I mean, where is the Chinese knockoff where they're actually selling these things for $15, $20? Because that's about what they cost to put together. They're not made of anything but tin. Maybe the lenses and the glass are expensive to manufacture, but these tubes, no. This tube is like maybe $5 worth of components. Selling them for $499. A little mad about that. I'm going to look up what the focal length. 254, remember, 2,500 millimeter focal length on this bad boy is $4,000. And this is why I say they're gatekeeping. Because here's your standard flat earther camera. The P900, which is about 5 to 10 years old now, is a 2,000 millimeter focal length. Meaning this thing at the time was $1,000. Now they're like $500, and they have a P1000 that's actually 2,500 millimeter for $1,000 that beats out this 10-inch Meade for focal length. Right? So you come in here with the old cool pics and get better, more accurate pictures of everything than an actual system that's designed by the scientists to tell you that the Earth is a ball spinning through the galaxy at 9 bajillion miles an hour. Oh, look at that. You're going to spend $4,000 to pretend you're riding around on a little rocket ship Earth, floating around spinning around the sun. We're all just stardust, man. We're all just stardust. What a crock of shit, guys. You think that you're setting up your telescope and you're swinging around on this Earth and none of those stars move any different than what your telescope thinks that they're going to move? Really? Your equatorial mount invented in the 1700s? The North Star that hasn't moved thousands and thousands of years since all of recorded history, that thing's been sitting there. The equatorial mount proves flat Earth. This proves a globe. I keep saying proves flat Earth because it does. It proves the Earth's flat. All right, regardless of what the stars are doing. I haven't been to the southern hemisphere to see the stars for myself, but it doesn't look like they're rotating around a pole down there. It looks like they're kind of coalescing a little bit as they rotate, and the center of that rotation is rotating as well. It's not a fixed point in the sky. Okay, it's not got the same thing going as the North Star. So I don't know about what's going on with the stars down there, but an equatorial mount does not care anything about the shape of the Earth. Because you set it up to be flat, motionless, level, with the azimuth or whatever pointed at the North Star. And that's how they work. Has nothing to do with the shape of the Earth. Nothing. And with that, we're going to be out of here.